Okay. Module number 4. Today I'm going to start backwards. The assignment submission for this week is completing 4 Try-Hack-Me rooms based on the subjects covered in this module. So after going through all this, jump on Try-Hack-Me, find 4 rooms that cover the things that were talked about, do those, and that will count as the work for the week. Now jumping into the topics, it's wired and wireless vulnerabilities. As usual, there is a do I know this? This first section covers a lot of protocols, and I know that the protocols can work in either the wired or wireless. That's kind of how the book kind of had them out, looking at various protocols first, and the different ways that they could be exploited, and then talking about different ways that wireless things can get hit. So the first one is the Network Basic Input Output System, or NETBIOS, and the Link Local Multicast Name Resolution. Both of these are used primarily for host identification. Knowing their acronyms like NetBIOS NS, NetBIOS DMG, NetBIOS SSN, along with their ports, whether TCP or UDP, like TCP 135, UDP 137, UDP 138, TCP 139, and TCP 445, is definitely important. You must be able to recall what protocol goes with what port. Among these suckers, there are many vulnerabilities. For example, most Windows users don't change their workgroup from the standard installation. That's just workgroup in all caps. A lot of users have weak credentials on their systems and have a file and printer sharing enabled. So it makes easy attack for spoofing and poisoning of any authoritative sources and victims, because they use the general things and don't change them. So tools like Metasploit and Puppy make easy use of these default settings that are unchanged. The server message block has been a historically vulnerable protocol used in Windows systems. For example, one of the most widely known is Eternal Blue from the NSA. The successful exploitation of Eternal Blue allows unauthenticated remote attackers to compromise an affected system and be able to execute arbitrary code. That same exploit was used in WannaCry and a bunch of other malware for the exact same reasons of unpatched, default configured systems. DNS is a very important protocol. Any system that is acting as a DNS server must be hardened, must be protected, and must have a watchful eye on. Because successful poisoning of the DNS server can be pretty devastating. Manipulating a DNS resolver through injection and forcing the DNS server to send wrong IP addresses to victims. This can be a network-wide successful attack. So I must remind you, please defend your DNS servers well. That is a very, very lucrative target in your network. SNMP, Simple Network Management Protocol. It's great for enumerating services and checking and be able to deploy settings to a bunch of network devices in one shot. But like the NetBIOS, a lot of people use weak or default information on SNMP enabled devices. Nmap can gather information and brute force any weak credentials. So if you see a question that's asking about that, about how to break SNMP, Nmap could do it. Email. The ports that you need to know. They are all TCP, but it's 25, 465, 587, 110, 995, 143, and 993. Any email protocol must also be defended, because attackers like to use them to send spam. They can get a treasure trove of information off of email servers. So not only should you be familiar with the ports, you should also be familiar with the SMTP commands, like hello, its response, start TLS, RCP, data, reset, mail, quit, help, auth. Those you should know at least what they look like and what they are. The file transfer protocol. As with most protocols, they were built insecurely. And DNS, SMTP, all the ones that we've covered so far were all built without security in mind. FTP is no different. You can secure FTP in two ways. You could either use the File Transfer Protocol Secure, or FTPS. Or you could also use Secure File Transfer Protocol, or SFTP. That uses SSH. With either way that you choose to secure the file transfer protocol, remember to use strong passwords and multi-factor authentication wherever you can. Implement file and folder security, like using the least privilege principle. Using encryption at rest. Locking down administrator accounts. Keeping software up to date. Use validated encryption ciphers. Keep your back-end databases on different servers than FTP servers. And require re-authentication of any inactive accounts and their sessions. Windows. Continuing bashing Windows, because there's just plenty of shenanigans with them. All Windows versions, and I'm talking from Windows NT to 11, they store their passwords as hashes in the Security Account Manager file, or the SAM file. The operating system doesn't know the plaintext password, but the calculation behind NT LAN Manager, or NTLM, is known and very easy to calculate. for all versions of NTLM. Honestly, all the attacker needs to do is just record a hash from a victim and use that hash to authenticate. There is really no need to figure out what the plain text password is, because Windows doesn't do that. So if you're able to capture credentials on the fly using like T-Shark or TCP dump or Wireshark, and you see that packet that has the hash of a user, well, you have everything you need. You'll be able to authenticate as that user. KERBEROS and LDAP. A quick recap on how KERBEROS works, because it's not quite straightforward. A client sends a request to the authentication server. That authentication server will send a session key and a ticket granting ticket that is used to verify the client's identity. The client will send the ticket granting ticket to a server, a second server that handles just that role. That server will generate and send an actual ticket to the client. That client will present the ticket to the server it's actually trying to connect to, and then it'll be granted access. And of course, this entire process happens in the blink of an eye, but those are the 6 steps for a client to get access to a server that is within the KERBEROS system. Windows Active Directory uses the lightweight directory access protocol with KERBEROS for authentication. One of the most common attacks is the KERBEROS golden ticket attack, manipulating KERBEROS tickets based on available hashes by compromising a vulnerable system and obtaining local user credentials. If it's possible to get into the domain server or any system that is part of a domain, then the attacker can create what's called that golden ticket and be able to get into any system. There is a similar attack and to the golden ticket called the silver ticket. And that's really for services on a particular server, to getting things like the common internet file system or the Windows management instrumentation, using a security identifier in order to get in. So the golden ticket gets you anywhere on the network. The silver ticket gets you into the services. Either way, both are bad. The good old man in the middle, where an attacker places themselves in line between 2 devices that are communicating at either layers 2 or 3 in order to eavesdrop and or manipulate data being transferred. A layer 2 attack is usually using ARP and getting the caches of the victim and the server, or the victim and the router, to add a entry that shouldn't be there, or manipulating the spanning tree protocol in order to allow all traffic to flow through the attacker system and be able to see everything. There are a number of best practices against man in the middle. At layer 3, it could be a rogue router on the network to trick other routers to believe that the new rogue router is the shorter and better path. So some best practices would be to use a different LAN other than VLAN 1 as the native VLAN for all trunks. Administratively configure switch ports as access ports so that users can't negotiate a trunk or just disable trunking negotiation altogether. Limiting the number of MAC addresses that a given port on a switch can learn. Controlling the spanning tree protocol to stop users or unknown devices from manipulating it. Turning off things like Cisco Discovery Protocol on any ports that face untrusted or unknown networks or devices that don't need it. Any new switches should have all ports assigned to a parking lot VLAN until they're used. Root guard can prevent any port from becoming a root and sending upload data, like upstream data. Using dynamic address resolution protocol inspection. Turning on DHCP snooping to catch anybody who's trying to be a DHCP server. Using storm control to prevent broadcast and multicast traffic. And also using things like access control lists and policy enforcements. Are all of these a solution to it all? Yes and no. It all depends on the network you're working on. An attacker can force, if it's configured, can force a system to use a weaker encryption protocol or hashing algorithm. If you disable or remove those capabilities to run older encryptions, then the attacker has no luck. BGP, Border Gateway Protocol, is still very much used, and it is pretty weak, but the internet runs on it. It is a very common way to hijack a network by configuring or compromising an edge router and announce prefixes that haven't been assigned. If the announcement contains a route that is more specific than the legitimate advertising or presents a shorter path, the victim's traffic could be redirected to that attacker. Denial of service and distributed denial of service attacks are an annoyance. It's not like pass the hash, where you get access into something. Both of these do the same effect of just sending so much noise to a system that they're unable to process any legitimate requests. Because they're unable to do any legitimate requests, it looks like the system is down. It's really overwhelmed. It's not down, it's not offline, it's just trying to handle a massive wave of communication. The example that I normally use is whenever I do career days at schools. I'll ask 2 or 3 students to walk up to the front of the room, and I'll have the rest of the class tell the kids in the front 2 or 3 sentences at the same time, and it's the job of the kids in the front to tell the rest of the class what they heard. And normally what happens is the kids catch on to this, so they yell on top of each other, and it just becomes one big screaming match. And most of the kids end up saying, I didn't hear a thing. Maybe one might say, oh, I heard the last thing that was said. And that's pretty much what happens with either a denial of service or distributed denial of service. It's just noise. It's just noise that takes out the legitimate traffic from getting through. This one is a little more tricky. the reflected distributed denial of service attack. Attackers send source spoofed packets that appear from the victim, which cause the victim to respond to the intended target. In this way, it seems that the attack is coming from one machine, host A, rather than the attacker. This is usually achieved with UDP, and because it's using UDP, there's no way to verify the packets. It just looks like it's coming from a source, and we can't really backtrack. There's also the amplification. This is a form of the reflected denial of service in which the response traffic is sent by the unwitting participant larger than initially sent by the attacker. So you see in this case, the spoof packet was 64 bytes big and it went to 3 places. The combined response was way bigger than 64 times 3 to 3,000. This can overwhelm the victim by sending way more data than the buffer can manage. And again, all of these different ways, they're just ways to be annoying. Network access control sounds great at first. That, hey, at every switch port, we're going to record what MAC address is supposed to connect there, and that's the only MAC address that can connect. In theory, that sounds great, because again, in theory, the system, the desktop that connects to that switch shouldn't move, so it should be that one always. So that'll be the only device that can connect. Things happen. Computers die. Things happen where you have to put another switch or another device on that network. It is totally possible to bypass that. As long as you know what the device was connected to it, you can spoof the MAC address. It is very simple to spoof a MAC address in order to get in. Now, if you thought VLANs were safe, they're not. It is possible to switch spoof or double tag. In switch spoofing, an attack imitates a trunking switch by spanning the respective VLAN tag and the trunking protocol. So the attacking packet would look like it's coming from a trunk. In double tagging, there are 2 VLAN tags within the packet. This way, the first one gets stripped, and then the second one takes the attacking packet to the destination. If you are using easy to guess or solvable network topology with your VLANs, like say using VLAN 1, 2, 3, 4, 5, it's totally possible for an attacker to craft packets using things like Scapy and putting a packet with multiple VLAN tags, and as it goes through the network and it passes through the many VLANs, each time it passes, it'll just strip that VLAN tag until the packet ends up where the attacker originally wanted it to go. DHCP starvation attacks and rogue DHCP servers are more problems to deal with. These are the 2 most prevalent attacks against DHCP. In starvation, an attacker will broadcast a large number of requests with spoofed source MAC addresses. If the server responds back to all the fake requests, then there are no more addresses for anybody else to use on the network. Once this is achieved and the DHCP server's pool is exhausted, then it's totally possible for the attacker to set up a rogue DHCP server and grab those new requests into their system. And now they can do anything like change the default gateway, be able to spoof spoof anything, and listen in on all traffic. Moving on to the wireless realm, starting with the rogue access points. The rogue access point is the most simplistic of the wireless-based attacks. An attacker simply installs a rogue access point in the network to fool users to connect to that access point, creating a backdoor and obtaining access to the network and its systems. It doesn't always have to be an attacker, though. Let's say you are the network admin for an organization, and you set up the perfect configuration to kick people out, and you feel your network is secure and awesome, but an employee in accounting, let's say, doesn't like that they have to get a 509 cert to attach up to their phone in order to get onto the work network. They think it's too much work. So what they do is they take a little ride to Staples or Best Buy, buy themselves a cheap access point, go back to the office, and connect it between the wall jack and their computer. Now they have an access point that doesn't have all these security measures, and they can connect their phone and laptop to the work network easily. That is also a rogue access point and should be treated the same. An evil twin is exactly as it sounds. Somebody uses something like, the easiest implementation of an evil twin is the Wi-Fi pineapple, or it pretends to be a network with the same name, the same SSID, and because it's closer, it will be able to convince other systems to connect to it, and just like that, getting computers to connect to the evil twin now opens the door to everything and anything. De-authentication attacks can cause legitimate wireless clients to de-authenticate from a legitimate access point or router, and then have them try to either connect back or connect to the evil twin. This device over here on the right is the flipper. It is taking a while to get out to market, but both this and the Ponagachi do the exact same thing. They de-authenticate systems from their wireless network, and in that time, they're able to pull in enough information in order to be able to attack the network. This is a picture of a Wi-Fi pineapple, if you've never seen one before. They're a couple $100. They're relatively easy to use and can do quite the damage. I don't suggest walking into a security conference like DEF CON with them, because everybody knows about them and there are lots of people who know how to brick them. Attacking the protocols that we depend on for securing wireless access points is definitely a cat and mouse game. we should not be seeing any wireless network that is using WEP, the old way of authenticating wireless networks. If you see something using WEP, run away. That is old, outdated, and is very easy to break. WPA is also easy to break. They are, though the two are susceptible to different kinds of vulnerabilities, they are both susceptible. While WPA isn't as susceptible to the things that affected WEP, it is totally possible to capture the four-way handshake and brute force the key in order to get in. The suite of choice for this kind of thing is the aircrack suite. Here is a picture of the steps in order to get through that four-way handshake. Now, it used to be that all these different ways were kind of complicated, and you had to use a number of, like the aircrack suite, that's like 4 different tools that you have to use at once in concert with each other. And then in 2018, the key reinstallation attack, or crack attack, came out. This broke through WPA2 by changing the key used, reinstalling the key with a bunch of zeros. The attacker is able to decrypt all traffic. It's pretty wild and sent everybody up in arms when this vulnerability came out, and it came to light that, hey, many access points were vulnerable to this, and the only fix that really existed was for those that were still being managed to update, and those that are no longer managed by the manufacturer, you had to buy a new device. But when we're talking wireless, we can't forget Bluetooth. There is 2 main ways of attacking Bluetooth. That is BLUEJACKING, which attackers will send unsolicited messages over Bluetooth. So, more of an annoyance. And BLUESNARFING, which is stealing information. And of course, there's tools that you can use to do that, both hardware and software tools to attack Bluetooth. RFID is another radio frequency infrastructure that must be protected for things like skimmers, for things like copying cards, like ID cards. These are all different wireless protocols that we use on the day-to-day basis that need to be in our sites, that need to be protected. Any questions, or did I just scare the pants off of you? I always suggest looking at your own hardware. Make sure that your wireless access point is not vulnerable to the crack vulnerability, for example. Turn off Bluetooth when you don't need it, and also your Wi-Fi when you don't need it. Turn off things like the NFC when you don't need it. Put your credit cards in an RFID pouch so that nobody can walk up and take the information. And also be aware of your critical infrastructure, things like DNS and DHCP, and what's on your network. Because you never know who will decide it's a smart idea to go get a access point from a nearby store and try to make their life easier, but give you a headache. So like I said earlier, the work for this week is more Try Hack Me rooms. Pretty simple and straightforward, but also a whole lot of fun.